We're going to get started here. There's a few more people trickle in, but thank you everyone for joining us for our first As the Prop Turns webinar. And we have a little something to kick this off real quick.
And now, for the next 30 minutes, As the Prop Turns. Brought to you today by Ranger Tugs and Cutwater Boats. Quality cruising and real community.
Bringing back the old school.
Yeah, that's some memories for you. So I want to take a quick second and introduce everybody that we have from the factory team here, starting with our VP of Fluid Motion, which is Ranger Tugs and Cutwater Boats, and that's Jeff Messmer.
Morning.
We also have the general manager, who's Andrew Custis. Everybody knows him.
Morning.
And Kenny Mars, our customer service manager.
Morning.
Fell off the bow rail.
Tim Bates is our factory delivery captain and our engine specialist.
Morning.
Brian DeCout is our marketing associate, and he's worked hard to put together the presentation this morning with the help of Andrew and everyone else.
Good morning.
And my name is Sam Bissett. I'm the marketing director, and we have just a couple housekeeping things real quick before we get started. One question we get a lot of is, can I get a copy of the presentation? And the answer to that is absolutely. So as soon as we're done, actually, as soon as we can get everything put together, we're going to send an email out to everyone that has a copy of the presentation. It has a link to the full video on YouTube. It has a copy of all the questions and answers. And while we're talking about that, if you haven't seen yet, on the bottom of your screen, there's a Q&A button. And if you click that, it brings up a separate window where you can ask questions. While there's a lot of questions coming in already, so we can tell we're probably not going to be able to answer every question online. So we will have a log of these, and we'll follow up with answers over the course of the next week. So go ahead and ask them. If we can't get to them live, we apologize, and we'll get to them as soon as possible. Andrew's also going to be using a DC calculator later in the presentation. That is available on the homepage of Tugnuts right now. So if you go to tugnuts.com, there's a battery usage calculator file. And you don't need it to follow along with the presentation. You're better off just watching Andrew use it. But after the fact, you can download it there.
Cam Marco's online with us also this morning.
Oh, that's right. Yeah, I'm the janitor. Good morning, everybody.
Sorry, Marco.
It's all good.
You weren't on when I made my notes, buddy. I apologize.
No worries.
Hilarious. Customer service superstar. And at this point, I'm going to turn it over to Andrew Custis, the general manager.
Well, welcome everybody. Thanks for taking the time out of our day to do this. But we wanted to put together basically a presentation to help basically when we go out and cruise, and to help understand your battery levels and what the device is on your boat and kind of how much they actually take and use. So we put together a presentation that walks us through kind of a trip, as if we were leaving from Des Moines, going up to Susha Island and the San Juans, and heading back, and kind of 3 different categories of how we would use our batteries and power and things around that. So I'm going to share the screen so everybody can see, and maybe Sam, you can confirm that you do see that this is what everybody's seeing right now.
Yep, looking good.
All right. So this is the first, as Sam mentioned, it's the first episode of our As the Prop Turns. That's today, and we're going to try to do these hopefully once a week or every other week on different subjects. So in case you don't know who I am, I'm Andrew. I'm the general manager. I've been with Ranger Tugs and Water Boats for over 10 years, and worked with Jeff and Kenny and Tim and Marco and a lot of these guys for many, many years. So thanks again for joining us. This is a brief. I just did we did a picture of myself. This was kind of a picture in the past when I was working with Johnson Outboards. That's actually not the case, but we kind of led that up to, we thought this would be a good topic with Tiger King at the top of the news. So I am we call myself Drew Exotic. All right, this gets into basically our start of the cruise. And this is our, for a lot of you that have taken delivery recently or in the past 6 months, this is actually a picture of our Des Moines factory delivery center. So we actually have close to 400 feet of dock space where all of our owners can come in from all over the world and do our 2-day factory on the water training which is with Tim and Kenny and Ivan. That's there, but a great place to hang out with local things to do, and it's all private. There's actually a gate right here that's set in, so all the boats on our dock are secured. So basically the trip, like I was saying, we're going to go from Des Moines to Susha Island. We're going to talk about using some power underway of what we might run during that. We're going to talk about being on anchor at Susha Island, and then we're going to talk about kind of our run back from Susha into Roche Harbor. And then off to the right, you'll see just kind of a little bit of a trip. You know, this trip running up shows the trip all the way from Des Moines up to Susha with about a 94 nautical mile run. And so this slide was based off a boat that does 24 knots in an outboard boat. So, and that was approximate fuel usage that's there as well. We're going to talk, looking at it, we're going to talk about, how to manage our power and what devices, we might run and make sure, what's set up before we leave the dock. And then we're going to talk about what devices and how to manage the power underway. So getting right on to it. And then also talk about managing power at the anchorage. So this is a picture here of the anchorage at Susha, and then a little bit of a map and a chart kind of showing where we would be. And then finally, at the end of the presentation, we're going to talk about leaving and coming back to the dock and hooking back into shore power and what the best practices are. This right here, this is a picture of Roche Harbor. So this is where we're going to end up, and a picture of where we hold our rendezvous in September every year. So if anybody ever kind of wonders of what the scenery looks like and around, this is all the boats and all the dock that we end up taking up there at Roche Harbor, which is really a fun trip. All right, so the first thing we're going to do is we're going to prepare to leave our home port. So wherever that might be, there are some things that we want to check. And the first is probably shore power, of making sure, before we get to leave on our cruise. And the first thing you'll want to make sure before, especially if you're going on a cruise where you're going to anchor out, and you're going to want to make sure battery levels are charged. So it's good practice if you're on a dock and you have power available to charge your batteries ahead of time. And, versus starting out with a battery that's at 50%. It's also good practice to be aware of your battery age and condition of the batteries. Batteries tend to, over the years and the time that goes by, they tend to deplete a little bit. And so that will take a toll on your remaining amp hours and some of those things that we actually go through. And then thinking ahead of time, still, you want to verify that you haven't intentionally left something on. So before we leave the dock, and we'll go through some of those things, but you haven't left things on, such as your inverter. And then also be prepared to save power. And some of those things that you can do to prepare yourself, and this is kind of specifically in this with an outboard power boat, is heat up your hot water. If you want to have hot water on your trip, have your hot water hot water heater turned on your shore power breaker a couple hours before you leave, and that way you're not having to run. And we're going to give you some examples of that as well. And start out with your refrigerators cold and ready to go. Some boats have 2 refrigerators, some boats have 3, and some boats have 4. But make sure they're cold, because we're going to talk about, the duty cycle of a refrigerator, and, versus a refrigerator that's running 100% of the time for the first couple hours of your trip versus running 50% of the time. So that's just a couple examples here of, be prepared. So have some of those things ready to go before you start the trip. So the first thing about leaving the dock, everybody, there's always question about battery position and where we should have batteries. Our switch panels are pretty darn easy, unlike a lot of other boats out there that may have combination switches or anything else, but ours are single turn switches. So they're very simple to have on. So you'll want to have things like your engine switch on. So these can be located in a couple different locations depending on the model, but have the engine switch on. That's going to allow you to have power from the engine battery bank to start the engine. The house switch, having that on, is going to give you power to be able to run things like your chart plotter and your DC or battery driven components. So your refrigeration, your lighting, chart plotter, sonar, radar, a lot of those things, that's what the house is going to control. So make sure that's on. And you'll note too, as you see here with this picture, that the emergency parallel switch is off. And we're going to go through that a little bit with you of how to run and utilize that emergency parallel other than emergency uses. And then finally, your thruster switch on. You'll know pretty quickly if you don't have your thruster switch on as you go to leave the dock and your thrusters don't work. So you want to make sure you have that on before you head out. Some of the things that also in preparation before we leave are, making sure that your batteries are charging between 13 and 14 volts with the engine running. And so as you go, you get your battery switches on, you start up your engine, and there's ways to monitor this, but you'll want to make sure those batteries are charging. So many times we'll hear where maybe someone didn't have their batteries charged up, or they forgot to have their battery charger breaker on when they're at the dock, and they start out and they do their trip and their engine's charging, but their house wasn't charging for the 2 hours or 4 hours of the trip they took. So this is a way to monitor and look and know while you're cruising kind of what your batteries are doing. So we've given you an example of a Garmin chart plotter. You can probably see my cursor here. of how to kind of watch as you're cruising to see what your battery levels are. So for instance, this has speed up here, it has heading, it has GPS heading, and then it has heading. So, you know, something that you might not need, you already have GPS heading, you can take, you know, this heading sign here, or maybe this time of day here, and it gives you an instruction of what you can do. So if you want to view your house batteries, you can press and hold that, and then you can scroll down to find system, and then you can find unit voltage, and that's going to give your house bank voltage under that system and unit voltage. And then maybe the time of day, you can go here and you can set the same way, press and hold, press the engine tab, and then select engine voltage. And sometimes your engine voltage will also show over here on your engine display, but I like to have them kind of right up where when I'm running. So when I do start the engine, I can see, I can watch, you know, the first battery that's most likely going to charge is your engine battery. So I can watch that engine battery go up to 13, 14 volts. And then you should see the house to follow that and watch your voltage that climbs up, which tells you that good, I got good charge going into those batteries. So for the first section with that, does anybody have any questions that we might be able to answer on that first kind of leaving the dock of where we're at?
Yeah, there are some questions here, Andrew. I think Kenny's going to come back online, but
yeah, I was just typing up some or responding to some right now.
are there any that pertain to what Andrew went over that he should answer for the group?
The one that George was asking is, can I start the engine on shore power? George Silverman, so 31.
Yeah, and that's a good question. You absolutely can. And all basically, when you start, every alternator on an engine has a voltage regulator. Just like if on a battery charger at the dock, every battery charger we put on our boats are fully automatic. So if you start an engine at the dock and you're plugged into power and you have a battery charger going, it's just going to take over, but it's still going to limit. So you're not going to overcharge batteries.
And then Dale was asking, why would you ever turn the thruster switch off, battery switch off?
Yeah, so that's a good question too. If in the manual of all your thrusters, they'll actually tell you when you're not using the thruster, if it's at the dock or anywhere else, it's better to have the switches off for those components in case you have a fault of some sort where you don't have power going to the unit.
Okay.
And
then one of them Dave was asking is it okay to leave all switches on even at the dock with the exception of the parallel switch? Which kind of ties into what you're just saying there too.
Yeah, it doesn't hurt you. It doesn't hurt anything to leave the battery switches on at the dock. It's a recommended practice to turn off and cut power to those batteries. And one thing that, you know, a lot of people ask, when you turn those battery switches off, do my batteries still charge? And yes, they do. So regardless of switch position, your batteries will charge. But to answer that question again, it's good practice to turn off the battery switches in case you're not on the boat and there might be a problem with one of those components like a thruster or engine. Or, for example, it's good practice to do it even when we get into anchoring, which we'll talk a little bit about more, of accidentally leaving your ignition on to your engine, which would, you know, draw power. So I think it's just good practice to shut those switches off when you're not using them.
Are there any other ones in there, Jeff, that you see we should hit?
Well, there were a couple people asking about leaving shore power hooked up all the time, and if that was okay.
Absolutely. Yeah, I mean, your batteries are designed, the batteries on the boat and the charger on the boat, basically leaving the shore power. I think that, you know, we get into another segment on shore power, you know, on maybe our series number 2. But the general question of having it plugged in and onshore power and a battery charger on is perfectly okay and recommended, because a lot of the time, you know, for myself and in, you know, my boat, I would have it in the marina and I wanted to keep my refrigerator going. I didn't want to have to empty out my fridge every time I was done on the boat or going home. I wanted to keep it going, and able to do that. In order to do that, I needed to leave the battery charger breaker on to keep up with the batteries. So there's no problem doing that.
There's another one I just saw, I think from John, asking if the auto pumps will still work with the battery switches off, which, yeah, all of our bilge pumps have been wired hot to the batteries. So even if the boat's at the dock plugged into power with the switches off, like Andrew was talking about, those bilge pumps are wired hot and they will still have power to discharge.
Yeah, and that's, I think, Kenny, that's another good question, that maybe just quickly explain, you know, what we call, you know, in the owner's manuals of the boats that are out there, you know, the 24/7, you know, fuse block, just things, because that's a lot of question and concern about shutting battery switches off of things like carbon monoxide detectors and some of those important devices that have to be 24/7 powered.
Yeah, and those, you'll still have a switch inside that like, say for a bilge pump, you'll have a switch, you know, at the helm or, you know, back by the cabin door. That would be off the battery switch. So if that's off, that is not a part of the 24/7. It's only the float side that's 24/7.
And I saw that another question there is there a separate switch for the thruster? And yes, there is. On every boat that we build, there's a separate switch for the house. There's a separate switch for the engine bank. And there's a separate switch for the thruster bank. And then there's a separate cutoff switch for the inverter as well, which we have not covered in this presentation. But there is for those four systems.
Great. Okay.
All right. Okay, so now it's time to get underway, where this is going to get a little bit more involved of power management as we're cruising, where, you know, a lot of people might not think when we get underway, we don't really care about power, but I'm going to go through a chart and everything later in this presentation about underway power, and then also at anchor power, which I can help explain. This shows, this is a nice picture we chose of flat, calm water with our kayak ready to go cruise. And it's also a reason we chose that picture is to, you know, explain a little bit when we get into solar and how something like that might affect it. But this would be heading right out of Des Moines, heading up to Roche Harbor or Souche Island. So power management underway again. Here's a good question, and one that Bob had asked earlier. You know, how does my boat charge batteries while I'm underway? So we talked a little bit just about shore power. We know that plugged in at the dock, we have a battery charger to charge batteries underway. But what is actually charging the battery banks underway when we're cruising? So an alternator. So on all of the engines we use with Yamaha F300, this presentation is kind of based around the F300, which would be very similar to a Suzuki 300, and then our Volvo D4 diesel inboard. And those alternators, as you see with a F300, can provide power up to 70 amps, which is a significant amount of power that can go back into your batteries. And then with a diesel, it can provide power up to 115 amps. And you have to remember that these numbers, which again we'll go through, can vary by what speed you're cruising at. So if you like to cruise at 6 or 7 knots or displacement speeds, you're not going to be putting in 115 amps. You might be putting in half of that or even a third of that. So these numbers, when you go up to 70 amps or up to 115, is based on, you know, running the engine more at that 80 to 90% range. And then the other way that we have to charge, which really, you know, I would say 90% of our boats have, is the solar panel. And, you know, during a lot, you know, whether it's during the sail or during training or any of that, people wonder, why do I really need a solar panel? And the main reason I tell anybody with the solar panel is, you know what, if you never plan to do a trip like this, and you never plan to go up to Susha and anchor and get away and do the things we love to do, then a solar panel is not really going to help you. But a solar panel is going to really help if you want to anchor. There are some people that have maybe a mooring buoy that's out to where the solar panel can provide a significant amount of power in full sun. And in full sun is, you know, June timeframe. But this is pretty well, we'll give you an example of what that's putting out as of yesterday as a solar panel on the water. Some of the things that, you know, you might run underway are things like your chart plotters. In the chart that I'll go through, I'm going through a single chart plotter, but for boats like a Cutwater 30 or maybe even some Ranger 29s where you have two chart plotters, you'll have to take that into consideration. And you'll take into consideration of usage like a VHF radio or cabin lights, which, you know, we're probably not going to be running cabin lights throughout the day as we're cruising, but at nighttime, absolutely. And it's important because a lot of those lights, you know, you forget you have on, but it's good to kind of note those different things. Webasto diesel heater, you know, this morning, you know, it's a little cold. I'm cruising up, I'm heading to Susha Island, and I'm in an outboard boat. The way I get heat is by the Webasto diesel heater. And so you have to take that into consideration for power management. Where an inboard diesel, a Ranger 29 or a 31, you have what we like to call your free heat, and you have a heater that runs off the engine. And so your underway heat, which is a little bit of an advantage if you're really worried about battery power while you're cruising. But so on a 29 or a 31 on an inboard, you know, if you want heat, make sure to utilize that. It's just like your car, and it's got a closed cooling loop that provides that. And then refrigerators. You know, refrigerators on the boat are, that's the device that you're going to run 24 hours a day. I mean, when I'm out, you know, I go on a 2-week-long trip, that refrigerator is never off. And so, you know, understanding what those refrigerators draw and how to manage the power around that is important. And we'll go through some of the refrigeration and how that works. So this is another slide. So this is AC power management underway. And we're going to talk about, you know, utilizing the inverter, you know, things you might run. You know, a lot of the questions we get when we're up cruising is, what can I run on my inverter? Now, you get on a Ranger 29 or a 31, the inverter will not run the water heater. It's not hooked into that breaker panel on there. But on a 23 or a 27, it is hooked in. And because the main reason is on a 29 or 31, like I explained, you don't need to run the water heater or your cabin heater, because it's going to automatically heat water on a diesel where an outboard is not. And so we're going to look at something that shows you, you know, how to run. If you did want to run a hot water heater when you're cruising up, which I've done many times, but you have to be very cautious while you're doing it and understand power and what this does to the batteries when you cruise up. So this is where we'll go through some of that chart. The reason we're bringing up the parallel switch here, and to talk a little bit about, before I open the chart, a little bit about charging relays. So those are known as, Blue Sea calls them an ACR, which is an automatic charge relay. We shorten it up and call them a charge relay. The parallel switch, and I'm going to go back on the relays, but the parallel switch, just so everybody knows, will combine these two banks of batteries. So when I switch the parallel to the on position, it's going to combine the house and the engine batteries together. So as an example, this is on a Ranger 27, where I have two house batteries equaling one bank, and I have one engine battery in that bank. So combining that parallel is going to combine these two banks of batteries. And if you're running a hot water heater, the only reason why you would have that parallel on is because of the charge relay. So let me give an example. You're running the engine and the alternator is going directly into, from the engine, that charge is going directly into the engine battery bank. Once you charge up your batteries on that engine bank and the load is not that high, it's the charge relay is going to basically open or connect the next bank of batteries in line. And how that works is that charge relay has sensing relays inside that basically say, okay, when you get to 13.2 volts, when it sees 13.2 volts, I'm going to allow the next battery bank in line to charge. So here we go, engine runs, it's charging, it's got up to 70 amps on an outboard. It's going to charge up that single engine battery really quick, and then it's going to go to the house. Where that will mess up is if you're running something like a hot water heater that's going to draw that engine. When I turn that down, that's a heavy, when I turn it on, that's a really heavy load against the batteries. And so what that means is that's going to draw the voltage down. So you might have been watching it on your chart plotter. You might have been at 13.5 or 14.4 volts on your watching it on your chart plotter when you're cruising. You turn that hot water heater on with the inverter, that might drag it down to 12.8 volts to where that charge relay now disconnects. And so it's still putting charge into the engine, but it's not putting charge into the house. And so the reason we would engage that parallel is it's going to tie the house and the engine together only while we're cruising. So it's forcing the charge into those two batteries no matter what. It just becomes really important that you understand what you're doing. And again, this really pertains to an outboard. But you understand that when you're finished, you heat up hot water or you're running a microwave or a heavy load, that you gotta, once those get turned off, you need to remember to turn that parallel switch back to the off position so you don't accidentally leave it on when we do go to anchor. So what I'm gonna do now is I'm gonna show you what it looks like with this worksheet, which we've put on the tug nuts. And it was, Sam said it in the introduction, it was on the homepage. I'm not sure sometimes it gets off there pretty quick, but if anybody.
It's on the left-hand side. It's still there. It's on the,
okay,
in the attachments bar on the left-hand side.
Perfect. Okay, so they can see it. So this is just an example. What we've done is I've put in, Kenny and I went and we actually took an amp monitor and we measured, this is based, if you look up here, it's based on a Ranger Tug 31. So we turned on cabin lights and we measured, what the amperage or wattage was of each one of these to give everybody an idea. So when you download this chart, these are real numbers that were based on a Ranger Tug 31, but they're going to transfer over to a Ranger Tug 23 or a 27 because all of our boats today use a NovaCool 4 cubic foot refrigerator. So those are going to draw the same amount of power. But this example that I'm going to create real quick is I'm going to create something while underway of things we might be running. And how it works is, we're going to be running, we started our trip underway. We have a 4-hour trip, give or take. So, I'm going to put in the number 4 hours because I'm going to have my Garmin VHF on. The autopilot display, we didn't get a real amperage use. This was display only without the actual pump working. So I'm not going to use that for autopilots. But, we might run for a 4-hour trip. We might run a water pump for, maybe even, 15 minutes or a little bit of time during, if we're, washing hands, which we all know is important, for things like that. But you can adjust the hours down. So one would be 1 hour, of course, a quarter of an hour, that type of deal. Wine cooler. On a 31, it has a wine cooler. A lot of people are going to be running that. I'm just going to use the 4 hours and pretend we're doing it during the day. So we're going to run our wine cooler for the 4-hour trip. We're going to run our Garmin chart plotter. We're going to run that for the 4 hours that we're cruising. We're going to run, maybe we're listening to music. I like listening to music when I'm cruising too, but I'm going to have that going for the 4-hour trip. And then our outside, this 1.7 cubic foot refrigerator, that's going to be on most likely, keeping it cool. And then the inside refrigerator. I won't get into the toilet or the diesel heat because right now I'm giving you a comparison on a Ranger 31 where I'd be using that free heat again while cruising. This is where it gets pretty interesting because if you look on how I have this is this on a Ranger Tug 31, there's 4 banks, 4 batteries in a house bank. And each one of those AGM batteries have approximately 110 amp hours per battery, meaning we have a 440 amp hour bank of batteries. I put in operating temp because temperature of batteries does matter on their efficiency. 80 degrees is about the best efficiency that you're going to get out of a battery. And then I did depth of discharge. So I did to 100% of discharge. And that's not advised to run your batteries to 100%, but I'm going to use the chart showing you 100% and kind of where that is so it makes sense for everybody. So right now, and then a couple of these, I mean, you can actually go into figure in efficiency of a battery. So if your boat's 2 years old, you could figure in that maybe my battery efficiency is at 85% instead of 100%. So we're basing this on 100% brand new, perfect batteries that are there. But if you look down with what I did and put in 4 hours, this is just for our trip underway, 4 hours on just these components, and you scroll down, this is how many amps you're going to use in that 4-hour period of running up there. But what we haven't figured in is we haven't figured in what our engine's putting in. So, if I'm cruising at, I'll be on the conservative side. Let's say I'm cruising at 50% power and we're on a Ranger 31. So I'm running a Volvo 300 horse at 50 amps, about half power of what that alternator. I'm going to do a -4 and I'm going to take that out of there where now all of a sudden you see I got plenty of amp hours remaining in the battery. I can run everything that I'm doing for this 4-hour trip, still keeping my batteries at 100%, showing it's in the negative now, meaning I have plenty of amperage going back into the battery. But when you start running things, switching over from, let me switch back over now to an outboard to show at 4 hours going in and take that away. So I'm still positive even on an outboard at 35 amps. Now I'm going to go and I decide, you know what? I forgot before I left the dock, I forgot, I didn't heat up my hot water. Maybe I want to do that now. And so we figured in, it probably takes a little over an hour, maybe 2 hours to get your hot water really hot. And the good thing about this and about our hot water heaters is they hold water, hot water, for an extended amount of time. And so when we do get to our anchorage, as long as we're being conservative with the water and the hot water specifically, that will hold hot water for 24 to almost 48 hours. I found it 2 days, no problem. But giving you an example, 2 hours on a hot water heater. So you see we're at minus 72.6 amp hours. But if I run that hot water heater for 2 hours, I'm going to take away 52 amps. So that's basically what I would consume in that 4-hour run. But you got to remember, we're only running that for 2 hours, and we're running our engine for 4 hours. So, you might consider that, okay, that leaves it where maybe I can run my hot water heater for 1 hour instead. So I'm still going to get to that stage of being 100% by the time I get to anchorage. So this does it really well, where you can set up your own boat and figure in what you're actually using. But we also haven't figured in our solar panel. So on a day, we have a sunny day, we're cruising up, let's just say I'm 4 hours on that solar panel too. So that's going to help quite a bit. So maybe now when we do use the hot water heater for 2 hours, we're down to only consuming 20 amps. And then we also put in some other ones, a microwave. A microwave, you're not going to run a microwave for 2 hours. You're going to run a microwave for 5 minutes. And so you'll have to do that, that calculation on a microwave for a short time. But something like we took a Instapot. A lot of people talk about a crock pot or, cooking underway when they're cruising up, because we're in that free power stage. Right now we're in that free power stage, not using our inverter underway. But things like an Instapot, maybe that's better than a crock pot, because a crock pot takes a long time to do it, where an Instapot may only take a couple hours, to where I'm running an Instapot now and I'm still 100% by the time I get there. And then we did things that, like cell phone chargers, a cell phone charger, using your inverter, you do, I kind of miss this, but the inverter does take, if you're having it on for 2 hours, it does, even without powering anything, it does take about an amp an hour of what you're using. So, when you're running a cell phone charger, for instance, and we're going to run that for 2 hours, take into consideration that this, if I bring, these back down to zero, that you're using about double the power to charge a cell phone using your inverter versus charging a cell phone on maybe a 12-volt outlet or a USB outlet that's not going to require the inverter on, which is going to take that 1 amp of power. So there's a lot to cover. This is more like an underway, but a really good thing to kind of play with and work around per your boat that we've done. So hopefully that helps, make a little bit of sense out of, yes, I can run a hot water heater when I'm cruising with the parallel switch on, or yes, I can run my microwave or an Instapot or some of those things. You just have to be very aware of what this will do to your power if you're wanting to manage when you get on anchor. I'm sure this will generate some questions, but let me bring back up our presentation. So that gives a rundown of what the worksheet is, how to run a parallel switch, and how to actually use that parallel switch to your advantage to run those high-powered items. And then, things like the water heater and that side of things. So this would be a good time. I'm sure if anybody will have lots of questions that come in, and I don't know what you've seen, Jeff, come in, but did that, a lot of that make sense to you guys?
Yeah, that was fantastic. I think we've got a lot of great comments about clarifying some of that. Paul's got some questions on his 302. Paul, the 302 and the 32 outboard has twin engines, and it's a little bit of a different animal. So we'll answer those for you directly. Skip just took delivery of his new 24 with air conditioning and the soft start system. And Andrew, what RPM does he need to run that at to charge?
Yeah, that's a great one, and a perfect example of what we just went through of using the inverter to run a higher power device. So basically, we measured what that takes power wise. So we looked at. Let me open this back up for. Yeah, let me open it back up for Skip just to give a little bit of a presentation on that to give an idea. So. He has a Cutwater 24, and he's going to be very similar. It actually the same as what a 300 horse would have on it in terms of charging. And his usage is going to be, let me bring these back down to 0 so we can see exactly what the amperage is. So we're not running anything other than the inverter. And something like I'm just taking these out so it'll actually show what it is. So when we look, so just to explain a little bit more, was it Skip you said, Jeff, that's delivering? So Skip has an inverter powered air conditioning system, which we're doing on a lot of our boats now. And so that air conditioning system is going to draw something similar. Let me see what this water heater draws. So the water heater draws around 62 amps per hour to run. The air conditioner system runs about 35 to 40 amps to run, which is going to be, you know, a little bit more similar to like an Instapot. And so his RPM running at 35 amps would be based at really slow speed. What we found is getting that 35 amps to 40 amps is anywhere over 2000 RPM, which on his boat, he's going to be using that a lot.
So he needs to be somewhere around 2000 RPMs to keep his battery bank up while he's using his air conditioning.
Absolutely.
Perfect.
The other one I saw was Bruce was asking, why do you enter negative values for charging devices?
Yeah, because the positive values are amperage coming out of the battery. So that's basically you're using that. In the way the formula is set up is you're going to minus that on anything that has an output for charge. So that is a solar panel, an engine alternator, a battery charger at the dock. That would be battery amperage coming back to the battery. So you're going to make sure you have to minus the amount of hours you're running that to get an accurate read.
Andrew, one question on the anchor light. Do we know roughly what that is as far as how much draw it is?
You know, we did cabin lights, and you know, if you look, it's now the difference is they're LED, where the anchor light is
lights.
not LED. But
Okay.
Usually, say that again. So usually, the 10 cabin lights equaled about 10 LED cabin lights equaled about 1 amp of power. where one incandescent light, like an anchor light or a nav light, is about the same, about 1 amp of power. And that is something that we can go and measure, because that's a good one that we should have, had on there. But, nav lights you're not as concerned about, because nav lights you're using when you're underway and your engine's charging your batteries. But an anchor light is definitely something to consider. And we can, when we get into anchoring, we can look at maybe use the cabin light at 1 amp as, a substitute as like an anchor light that you'd have on.
Right. And Ben asked if he can replace his anchor light with an LED bulb, and you certainly can do that. A lot of people have done that over the time. Dawn's asking if it's okay to run her air conditioning with her generator while underway.
Yeah, that's something we didn't cover in this presentation. This is kind of a presentation based on kind of a Northwest cruiser or a boat without a generator, and how you can use your boat without a generator. But if you do have a generator, your generator is just like having portable shore power. So instead of using electricity at the dock, your generator's using fuel. But absolutely, a generator is meant to be there so you can run things like air conditioning in those, warmer environments that we're doing, where in our environment and a lot of our cruising is typically a little bit colder, especially in the mornings, where we're going to use more heat than we are air.
Okay. Sounds good.
Look pretty good.
Yep. Let's keep it rolling.
All right, here we go. So now we've arrived at Susha. So this is probably the first thing Kenny likes to do. I guess I'm kind of in the picture, so I'm to blame here. But we all like to get out, set our anchors down, jump right into happy hour, take our dinghy out, go catch some crab, or see if we can get some salmon. But the first thing you really want to do before you get to into happy hour is go back in to start your power management to make sure that you can enjoy the happy hour and all that time with having plenty of power in your batteries left. So getting into that, these are things that you should do ahead of time. So we've arrived at our anchorage. We're going to go back, and you might ask, okay, I'm on the boat. Why do I need to turn my battery switches off? The reason, again, that you would turn, you're not going to turn your house power off, because then you're going to lose all your refrigerators, and you're going to lose your lighting and your anchor light and VHF if you want to monitor it for weather. But it's good practice, again, to shut off your engine battery and your thruster battery. And I'll tell you, for me, it has happened countless times where I jump right into happy hour. I hop on the paddle board. I get my fins on, I'm swimming around, and I come back to the boat 3-4 hours later, and my VHF is left on and my engine display is still on that's been using power. And I've already taken away from being able to power manage when it matters most at anchor. So make sure to turn those off. That'll eliminate the need or the possibility of you forgetting to key down your engine display. The thruster battery, it's not, I would say when you're on board, it's not as important, but it's a good practice. And if you get into the habit of turning your engine battery switch off and your thruster battery switch off at the dock or at anchor, that's good practice, and it'll keep you doing the same things for your checklists and pre-departures. And then definitely double check that the parallel switch is off. I run my parallel switch on a lot when I'm cruising, because I like to I'm a gadget guy, and I like to try and run everything to the max. But you have to remember to turn that parallel switch to the off position, so that way when we do go on anchor, we're not getting into all of a sudden we're using our house and engine together and then we can't start our engine. So it's really important. And then whoops, and then make sure that the inverter panel is turned off. That will also eliminate any accidental breakers being left on. So this is an example of a inverter charger panel on a Ranger 31. To turn that off, you'd press and hold that power button down for a few seconds. You'll hear it beep and that display will go blank. And then you know your inverter's turned off. We've put together a few pictures because we talked a lot about solar panels and how they charge. And we also talked about early on in the presentation about how to monitor batteries. If you have a solar panel when you're at anchor, this is a great way to check on what your batteries are doing, but also a great way to check to see what that solar panel is actually displaying and what it does. So we took we took 3 pictures of the most important things to see. And these are our most recent displays that we use. So this would be, I think we started using those a few years back, but it's very similar with all of them. The other part about solar panels before I go into it is efficiency. Just remember, like we showed you with our Ranger 27 heading up for Susha, we had the kayak on top. You have to, if you want and you need to use that solar, you have to really make sure that you're not shading the panels. And so that is by removing kayaks or paddle boards or things like that are going to shade it. So what I'll do is once I get all the toys in the water and everything else that were on top of the boat, I'll go up and I'll just look at the solar panel and make sure I don't see any shading on it. And then when you get in here, you can check the solar panel display. You can see this center section has an arrow going down, which is from the panel. From the panel, this was actually taken yesterday on a boat that was outside, and we had a sunny day, and we were putting 8 amps into the batteries. So that's a pretty significant charge, and we're going to show you some differences coming up too in the chart of what that solar panel will do. But those will provide, depending on the model, anywhere from 8 to 10 amps of power that you'll get out. So it's good to look. And then all you do is you hit that next button down here in the bottom left, and that will rotate between these 3 sections. It'll rotate from the solar panel to your bank 1 and to your bank 2. And so the arrow indicates which one you're displaying. These are going to flash through a whole bunch of different information. It'll tell you minimum voltage and maximum voltage. I really don't care about any of that information. I care about real time. And so you want to make sure that you're looking at this display and understand what bank 1 is. So all the solar panels are set up to be battery bank 1. Battery bank 1 on the solar display is your house power. So that's going to monitor your house voltage. Battery bank 2 is going to monitor your engine voltage. And that is what the solar is going to provide charge. It's going to provide its majority charge into the house, and then anything extra it's going to provide to the engine. So use that, but use that instead of when we're at anchor, instead of keeping your chart plotter on, which we'll do another kind of demonstration there, a chart plotter that's going to use power. Have your solar panel on that's going to provide power, and it's going to be a good way to monitor what your batteries are doing. So, and don't be alarmed, not to get really too deep into this, but don't be alarmed that you see all of a sudden we've arrived at our destination. We shut our engine power off. We make sure we start to do power manage. And our voltage, because I get that call or someone hits radios in and says, Andrew, I noticed after an hour, geez, my voltage is down to 12.4 volts. That's okay, because voltage is going to drop as you have power being pulled out of those batteries from devices. So go and look and start shutting off all your devices you don't need to get an idea of back where that voltage should be. And I'll cover a little bit more voltage and kind of where that should be in a few slides here. And this will go kind of the same way. This will go back into power management at anchor. Let's, what should we really be using while we're at anchor? Well, that depends on how many days. If you're going to spend 3 or 4 days on anchor, you're going to need every little bit of power you can get. Where if I'm spending 1 day on anchor, then I have a lot more freedom with batteries that are there. What should I avoid using on anchor? The one thing you should avoid when you're using on anchor is things like the inverter driven components that we just used when we were cruising, because those are going to bring down batteries really fast. This device here, this is a really good device. Sam, in our last cruising seminar we did, showed a picture of that. But that allows you to basically plug in. And so what we did today is we plugged in a Surface computer charger and showed what the wattage was of that charge, where we could put it on our worksheet to get an idea of what that would actually take. So that's a good component. If you want to know, you run, a lot of our owners may run like a CPAP machine. That would be a really good one, because if you're at anchor and you need that to sleep, that is one to figure out, because that means you're going to have to run your inverter to be able to power that, or a microwave. So let me open back up the sheet, and I'm going to do a little bit more of a demonstration at anchor. So these are all set again to 0. So I'm going to go back now that we don't have engine charging coming in. Let's kind of walk through, how we would use this. Cabin lights. So this is based, if you look, this is 10 LED cabin lights. And so when you look, 10 LED cabin lights alone is actually very efficient. It's drawing just about 1/2 of 1 amp per hour. That's there. So you figure in, I'm probably going to run, I like to be in bed by about 9 p.m. So I'm not going to run my cabin lights too long. But typically in the summer, when we're doing a lot more anchoring, our sunlight is a lot longer too. So, I might run my lights for 2 hours. But consider this, we're on anchor, consider, instead of running the overhead cabin lights, that there's 10 of those lights, maybe run a couple of your reading lights. A lot of our boats have single reader lights that are over the galley or in the bed, bed area. So use some of those where they're going to be drawing even less than that, just about 1/2 amp an hour. But if we run those for 2 hours, this will start to calculate. So this one is really, I'm going to put this down to 0 for now, because this one's interesting. A wine cooler, if you look, a wine cooler draws about 48 watts. A NovaCool 4 cubic foot refrigerator that we put in draws about 42. So that wine cooler is drawing more power than any of your other refrigeration in the boat. So if you want to conserve time and you want to conserve power, then, consider, I'm not a wine drinker, but Jeff could probably come onto this, but consider, drinking red wine for your trip that you're going to do, what you don't need to chill. So keeping that wine cooler, that could be, but I'll do a little bit of a demonstration to show. So a couple hours of cabin lights, the wine cooler or a refrigerator, those are going to be on. So we talked earlier about a refrigerator or a wine cooler. Those run on a duty cycle. And a duty cycle means the reason we told you to run the refrigerator, get the refrigerators cool before you leave the dock, is because they run on a 50% duty cycle. And what that means is once they're up to temperature, they stop and they only start back up when they need to cool again. And so that means when you go to cool, you know, be aware of how many times you're getting into the refrigerator. Every time you open the door, you let warm air in, it's going to want to turn back on to cool down. And so, you know, but these really, for a 24-hour period, as long as you are, you know, we're not in 100-degree, you know, weather, we're in our pretty average 70-degree weather, your fridge units are going to run for about half of the time. And so that's why I'm putting in here 12 hours instead of figuring in, this is on a 24-hour period. So 12 hours on a wine cooler, 12 hours on your, this would be a 1.7 as your refrigerator outside, and then 12 hours on your refrigeration inside. And then you figure in, you know, in the morning time, you know, I usually kick my heater on for a couple hours when it gets a little bit cooler in the morning. So I'm going to run my Webasto heater. You know, in 24 hours, how long are we going to run the fresh water pump? I probably use it more because I'm using that freshwater pump with an outside shower to rinse off when I'm done swimming and things like that. So, you know, you figure in, okay, maybe a half hour of total use. And that includes, you got to think, I'm using my freshwater pump for my shower as well. So if you're going to take a shower while you're on anchor or any of those things. So I figure in, you got about, you know, you got 2 people on board, you got a 15-minute shower apiece on that freshwater pump. And then the cool things, you know, exterior rope lights, those are always a little surprising because, you know, for example, on a 23 or a 27 or outside of some of those boats, they have what we call rope lighting or indirect LED lighting. And they kind of set that mood lighting, or it's not as bright. But what happens with those is those exterior rope lights have a bunch of LEDs in them. So they draw a lot more power than you might think. You can see it's double the exterior rope lights on a 31, and just your LED, you know, cockpit lighting is double what it would take to run 10 inside LED cabin lights. So be cautious, but I put that on there because it does at nighttime. It looks really cool to have those rope lights on that light up the walkway, but just understand what kind of power you would use. And then, you know, in 24 hours, I like to listen to the VHF weather. So I might listen an hour a day if I'm thinking about my next destination. I'm going to listen to my VHF for an hour. My plotter, you know, maybe I'm thinking I spend a night at anchor and I'm heading out. I'm at Susha today, but you know, the next day I'm going to head up. We're going to go into the Gulf Islands or something like that. And so I'm probably going to have my chart plotter on for about an hour because I like to create my trip. I like to plan and save a chart. I like to look, you know, if I'm going through any areas that have tides or things like that, where I can kind of plan that to base my departure. And so I'm going to run that for about an hour, the VHF and plotter out of that 24-hour period. And then the Garmin Fusion Stereo. I told you earlier, I like listening to music. I might run that for a couple hours a day. And, you know, a toilet in 24 hours, I might run, you know, very, very little. This wattage is based on when the pump is running. And so this gives us an idea with nothing coming in. You know, you got to remember, this is kind of a day's usage that we've put out based on a 440 amp hour bank. So on a Ranger 31, we're not even to 50%. So that's pretty good. But if you decide to use, you know, a microwave for 10 minutes out of the day, you know, all of a sudden, you know, you're getting up there quite a bit of being able to run that microwave, and, you know, which isn't a ton, but it's gonna jump your amperage up. But I do use a microwave or a coffee pot in the morning, even on anchor, and pretty typically I can get 2 to 3 days if I'm really, really cautious on power with exactly the way we build the boat. So again, this is just our usage that's going through as an anchorage. of kind of a 24-hour day showing what I might run on a 4-bank battery at 440 amp hours. And I don't know if we touched on that too much, but I'm pretty sure we did. But on a Ranger 27, to give an example, you're going to be at half of that because you have the same size batteries, but you have a 2 battery house bank. So now you're going to be at about 220 amp hours, which in this case would still work good, but you're going to be depleting your batteries a little bit more than 50%. And the rule of thumb is to take your batteries down to 50% before you recharge. And we'll talk about that. But what we haven't figured in is what our solar power is actually going to do. So we're using 136 amps in 24 hours right now with an available 440 amp hours. But if we run that solar panel at 8 amps and we figure, I'm going to get a good, on a good sunny day, I'm going to get 8 hours of sunlight that might bring in, where all of a sudden, as soon as I did that, I've only used 72 amps. So that means in 2 days, running everything that I have, I can easily get 2 days with about 140 amp hours and still above our 50% discharge on a Ranger 31. So that gives you a really good idea of what's there. You just have to be very cautious of what you use on the inverter. But microwave short periods of time will work as long as you understand that power. So there's a lot of information there, but that's the fun part about this chart is you can kind of create the things that you would use or wouldn't use. Some people never use a microwave. Some people don't drink coffee, so they don't care about a coffee pot, or maybe they use something to make coffee that doesn't require electricity, which I'm just not that fancy. Okay. So back on. So that gives a good idea of what we would look at, what we would use, and kind of what that would look like at anchor. So I'm sure, that gets, hopefully that kind of kicks some questions up there and see, was that stuff, did you guys understand that quite a bit, Kenny and Jeff?
Yeah, that was all good. I think there's a few questions on bringing a portable generator with you and using that to charge as well, or I guess use on anchor.
Yep, absolutely. And that's a portable generator is something you certainly can use. And again, that's going to be, that generator, the portable generator is not going to have an alternator in it like your engine would, or from that side, but it would be running your battery charger. And so here's just to kind of jump real quick back in. So this would give just an idea again of running, a portable generator. I put down here 2 different battery chargers, which we didn't talk about. But right now, in this case, with what we have, kind of with that, we don't need, to get 2 days, I don't even need a portable generator. But, things like running, a CPAP or something like that, which we talked about, that's going to use more power on the inverter, that you might need that generator, which is going to allow you to use your onboard battery charger. And so if you're using your battery charger, now you can do and realize, okay, well, if I, run my onboard battery charger at 20 amps for 4 hours, then I'm back to 100%. And so that would be the main reason of running a generator.
There's quite a few questions about what other systems or appliances draw, which we can measure, but is there a way that they can measure, the customers can measure what those particular systems are? For instance, the ice maker, or Yeah.
Yeah, the only way to really measure is to do what Kenny and I did that was on the boat, and we used a DC clamp meter, which gets pretty involved. But you know, if someone had you know, specific things, if we wanted to take and figure out what an ice maker did draw, we could do that, and then we could add it to the form that we can keep that kind of updated.
Okay.
But something you got to remember, you know, an ice maker on which we offer on a 29 or a 31 is not hooked into the inverter power. And so they're not going to be able to run on anchor anyways, an ice maker on inverter. It's really intended with an ice maker intended for shore power usage or generator driven.
Okay, great.
Any other questions you guys see?
I think we've handled most of the rest of them. Let's keep her going here.
Okay, sounds good. All right, now we have gone, we're getting back to, so we went through our anchoring, we went through cruising up. Now we're back to arriving at Roche Harbor. And Roche Harbor, of course, has power on the dock, and so that's kind of where we've ended our cruise. And this will give you a brief, you know, rundown again of shore power and how to hook it up and how to again make sure that you're charging batteries before you take off to do happy hour on the dock. So let's get right into that. Okay, we've arrived. The first thing we're going to do is, you know, plug in shore power. Now, if you're going to turn your refrigeration and things, there's several different reasons of why you might not put shore power or plug it in, but this is the average. We're going to go plug into shore power. And the first thing you're going to do is plug your shore power into the boat. And so you're going to actually put that shore power plug into the boat. And I know it seems tedious, but it is one of the calls we get all the time. When you put the cord in, you have to rotate the cord clockwise. And what that does is it locks in the grounding of the shore power. And so make sure to do that at both ends. Plug the shore power into the boat. You're going to go to the pedestal that's on the dock. You're going to attach the cord, but you're going to make sure the dockside breaker is off before you put this in, and I'll explain why on the next slide. So insert into the dock pedestal, rotate it clockwise, make sure it's locked in, and then you can turn the breaker on at the dock. Once you've hooked up to shore power, this is why it's important to go through and rotate that cord in to lock in the grounding, because we now, and this has been going on for several years, but you know, for several years we've installed these, but this picture is a picture of an ELCI breaker. And if we're working on a Ranger 31, that ELCI breaker is under the rear seat in the cockpit. You know, it is in a few different locations, but you should get to know and understand what that ELCI breaker does and the purpose of it. But the purpose is to monitor the grounding. And so this keeps basically your boat safe to ensure that you have proper ground on the boat and at the dock. And that could mean the pedestal, but the most common thing that we see with this ELCI tripping is from the cord not being inserted and rotated to where the ground is locked in place. And so, but make sure that's set to on. So once that's on, you'll have a green light right over here. You'll make sure you do not have a red light, which goes in and says reverse polarity. And reverse polarity is basically an indication that the polarity between a hot and a neutral, or it'll even sense no ground, is not there. So you always want to make sure you have a green light. The way you're seeing this switch, that's off the way it is in the picture. Turn it on. No red light on reverse polarity, and you're good to go. And then you're gonna, once you've hooked up to shore power, you're gonna flip your AC mainline 1 breaker on. to the on position on the shore power panel. And then on many of the panels, some of our panels have a rotary switch depending on age that will allow you to select between shore power, inverter, and or a generator. But what that does is that slide is a lockout, or even the rotary switch, if you had a rotating one, would be a lockout to where if you forgot to turn your inverter off, you plugged into shore power, and you turned your shore power breaker on, this will eliminate you from creating too much voltage going to the panel. So you can't hurt anything even if you are plugged into power and you accidentally leave an inverter on. So that slide is the whole reason it's there. If you were to turn that off, this slide would slide up and allow you to engage the inverter. If you wanted to run that, which we wouldn't be doing because we have power at the dock. And then once you're hooked up to shore power, you're going to want to make sure that you have your battery charger back on. And this is the main reason for this, is to keep your refrigeration going. If you have any lights you leave on or any of that stuff, you want to make sure that is on. We also put a note in here that batteries must be at a stage of voltage above 11.8 volts to activate the charger unit. And that's more of, I would say, a more recent thing, but the charger units are a lot like the charge relays that we talked about early on. They will sense if the voltage is too low on a battery, sometimes the charger thinks that that battery may be bad, and it's trying to isolate it. So it's important to make sure that you're not running your batteries down below that 50%. And it's important to make sure to monitor what that voltage is doing. And so before you leave your boat, turn on the shore power main, turn on the battery charger breaker, and then go and look at those monitors like we talked about. If you want to turn your chart plotter on and look at your engine and house voltage and make sure that you're in that 13 to 14 volt range, or look at your solar panel and look at that and make sure that that battery level is there. And then some of the boats even have an analog voltmeter where you can switch through and see the different banks of batteries. So, but it's important because we do get a lot of that too, where, you know, we've turned our charger on or we forget to turn the charger on. This will just keep you going in the right direction of getting in the habit of monitoring your voltage before you leave and even when you come back. And so now you're hooked up to shore power, your batteries are charging, your engine and thruster switches again are turned off. We don't need those. And you're going to leave the house power battery bank switch on. Again, we're going to leave that on. That's going to allow power to refrigerators and lights and things like that. And then you're going to want to just turn off all unnecessary items. So, you know, that might be if you forgot to turn the inverter off, you know, go and make sure that panel is off. Make sure if you don't need lights on, you can start kind of trimming back what you have on. And now back to happy hour. So we got our boat plugged in at the dock. This is at our rendezvous. We're hanging out. We're ready for the next trip after we leave that one and all set up. So gives hopefully that helps and gives everybody a good idea on our kind of first step of power management. So I think this is a good time to go through maybe any last questions that we have, anything else that we need to answer for you and get everybody on their way. So Kenny and Jeff and Tim, you guys there?
We're here. Most of the questions have been answered and everybody seemed to have really gotten a lot out of it. There's a few questions that I think we can take offline. We'll get back to these folks, and great job. Thanks guys for all your help, and thanks everybody for tuning in today.
Yep, absolutely. It was good. So hopefully this helps, and our next ones will go. And I think put in one more good picture here. That that's for Rocky, who binge watched it. You're welcome to take a snapshot of that if you'd like. But
All right. Well, thanks, guys. Thanks, everyone. We'll
yep,
see
thank you.
you next Thursday.
All
Thanks,
right,
everyone. We'll
You got it.
follow up with
Thanks.
copies of the presentation.
sounds great.
All right. Talk to you later.
All right.
See you guys.